Hello and welcome to our Chapter 4 practice problems. I'm going to be going through our probability questions here. So the first one is going to be your first day back at Hogwarts. Remember, I'm going to be going through these with the assumption that you have already attempted them, and I'm going to be going over the ways to solve them and things to look out for. So first part is the Hogwarts houses, the probability of picking Hufflepuff, mutually exclusive events. There's 87 Hufflepuff over a total of 346. Gives us our probability of 0.2514, or you can say 25.14% probability of picking Hufflepuff. Probability of Slytherin or Ravenclaw. So this is going to be probability of picking a Ravenclaw. It's 92 over 346 plus probability of picking a Slytherin, which is going to be 7 over 346, which is going to give you a probability of 48.84%, or you can say it's going to be 0.4884. Either one is fine. Part 2 here is we're looking at this 2x2 table here with the test of a certain disease, and specifically we're looking at a false negative type of tests. So we're looking at what is the probability suggested by the accuracy of the tests. So we're looking at the false negative rate or false negative test results, which was 4. So we say 4 over the total number of tests that are being run, 298, and we will get D is going to equal 0.0134, which the probability of error is low. Part 3 is we're going to be selecting the complement of an event. Number D slid down here somehow. That at least one of the 50 participants in the bone study are bone marrow donors. So this one, you really need to start understanding how complements work, and that it's the probability of the event not happening. Remember, 1 is at least 1, so anything greater than 1 is always going to be 1. So the complement of 1 or more happening is going to be C. None of the participants are bone marrow donors, which would be the complement of the event. D, we have a VA hospital with blood type, and so we're going to be looking at the probability of selecting certain blood types on a given day. First part is blood type A, which there's 560 people who have blood type A over the total of 5,059, which is going to give you 0.1107 or 11.07%, the probability of selecting blood type A. For blood type A or B, it's going to be 560 as blood type A over the total, plus probability of AB, which is 1253 over the total, and that's going to give you a value of 0.3584 or 35.84%. Part 5, we're going to be looking at another 2x2 table where they want us to find the relative risk. Relative risk is found by taking A over A plus B all over C plus D. Remember, we want to make sure a couple things with our table, that disease goes on top, exposures on the side, with our control group on the very bottom. When that is in your table set up, your values go as followed: A, B, C, D. When you have these values, you can put them in. So our relative risk will look like this. It'll be 45 over the total of A plus B all over the total of C over C plus D. Now, when you do this, you're going to get a very small number, and on some calculators, you're going to get significant figures, or not, scientific notation, which will be, for the top part, 1.498 times 10 to the negative fourth. On the calculator, instead of saying times 10 to the negative fourth, it'll say E negative 4. That's how they write it in the calculator. It's not an error or anything like that. Highly recommend, if you don't remember scientific notation, to review it, because with some of the values we will be dealing with, and when we go to certain exponent powers, we're going to get either very large or very small numbers, and writing in scientific notation will help save a lot of time and be able to put in the calculator. On the very bottom, you're going to get 6.8067 times 10 to the negative fourth. When you divide these out, you'll get 0.2200, which is our relative risk, which is letter C. Make sure you know how to put in e to the negative fourth or times 10 to the negative fourth as scientific notation. If you have any questions, always come visit me and refresh it. So number 6 here, we're going to be going into BMI category. We're going to be looking at Part A, the proportion of patients that are overweight or obese. So we're looking at just overweight or obese. So we're going to get 64 over the total of 204 plus 88 over the total of 204. And that's going to give us a value of 0.745. Now Part B says, what is the proportion of patients that are not a normal in the normal category? So there's two ways you can solve this. You can do kind of what we did in Part A, where you add the overweight, obese, and underweight, right? Because those are all the values that are not in the normal category. Or we can start using the laws or rules of probability that we're learning about, because it's definitely going to play a factor when we're moving on in the course. So the way we could do this is that we could find the probability of normal, which is 18 over 204, which is going to give you 0.0882. And if we want to find the probability that is not normal, so we want to find the complement, right? The complement of event A, or or BMI of normal, we could take 1 minus that probability and find the complement, which is 0.9118, which if you were to add up underweight, the overweight, and the obese categories, add them all up and divide by the total, you'll get this answer. So there's two ways you can definitely do it. One way is not necessarily always the right way, but one way is definitely going to be less work than the other. So understanding the rules and laws of probability are definitely going to help and play a huge role moving forward. So number 7, we're going to refer to this another 2x2 table here, and we want to know what the probability of the subject given a certain disease. One thing, always want to pay attention to what we're looking at. So we're looking at the probability the subject has a disease given that the test result is negative. So we're looking at subject who has the disease given the test result is negative, so we're looking at 9, but we're really only looking at negative test results. So it's going to be 9 over 321, which is going to give us a value of 0.028, which is going to be A. 8. For number 8 here, we're looking at a blood bank, people coming in with high blood pressure. We want to, what's the probability the next person's going to have blood pressure? Well, we have to go by what we're given. So there's 397 people who showed up out of the 1232 that had high blood pressure. When we divide this out, we get 0.322, so almost a third, or 32.2% chance that the next person who comes in will have high blood pressure based on the information that we've been given. Number 9, so we're looking at a permutation. You can see this written as 8p4. We're going to be doing np of r on your calculator. Some might have it np of x. So we're looking at a permutation, and so we want to use the calculator to solve this equation. You can definitely do it longhand using factorials, but once again, I want you to get real comfortable using the calculator. When you put this in the calculator, you'll get a value of 1680. If you need help seeing this on your calculator, please come see me during office hours or before or after class. Alright, and then the last one before I stop this video is we're going to be looking at the results of a marijuana drug test with the 143 subjects positive test results. So a big thing here is we have to create a new 2x2 table. Remember, disease goes on top, have a disease or don't have a disease, or if you want to say the test results are going to be going on top, and what we're looking for, the effect, is on the side. What we're looking at here is marijuana and not marijuana use. What we have to really look at is the wording. Everything in statistics, the words mean very specific things. We're not very wordy in general. So there were 143 subjects with positive test results. So here we have positive test results. There's going to be 143 subjects, and 24 of them had false positive results, meaning that they tested positive even though they didn't do marijuana. So the 143 is our total test results. 24 will go in the individuals who had a false positive rate, and that gives us 119 who did marijuana who tested positive. Moving along, there was 157 negative test results. So here's 157 negative test results, with 3 being false negatives, meaning that they did do marijuana but they tested negative. And then that gives us 154. So now we have our table set up and we have all our true values. We know that the total number of tests given is 300. What we're trying to do is find the probability that a randomly selected subject did not use marijuana. So we want to know how many did not use marijuana. So we're looking at this line here, did not use marijuana. There was 178 of them in total. 178 over the 300 gives you 0.593, which is C. Alright, I'm going to stop this video here, and I'll see you all in the next video.